Hello students. So let's continue problems based on areas of similar triangles. So question number 5, that's what we have to do. D, E and F are respectively the midpoints of sides AB, BC and CA of triangle ABC. So there is a triangle ABC and they have taken midpoints of all the three sides, and joining those three midpoints we get a triangle. We have to find the ratios of area of that triangle, that is DEF, and triangle ABC. Okay. So first let's draw a triangle ABC. Let's take a triangle. So let's take a triangle ABC. Okay. Inside that, we'll draw another triangle. Okay. That is, so let's say D is midpoint and E is midpoint. Okay. D is midpoint, E is midpoint, and let's draw one more midpoint from D. Let's say F is midpoint. Let's complete it. So the red color triangle is ABC triangle, and the green color triangle is triangle DEF. Let's write that. This is A, B, and C. T is midpoint of AB, E is midpoint of AC, and F is midpoint of BC. Midpoint in the sense AD value will be equal to DB value, and AE value will be equal to EC value. Similarly, FC value will be equal to BF value. Okay. So here we have to find, we need not prove anything, we have to find area of triangle DEF by area of triangle ABC. This is what we have to find. Okay. For that, first we have to prove the triangles are similar. That's what we have to prove. Quickly, let's just check whether the question is correct or wrong. So D is a midpoint of AB, E is a midpoint of BC, and F is a midpoint of CA. Okay. So, okay, here it should be E, and here it should be F. Let me change it. This is F. Okay. F is midpoint of AC, and D is midpoint of AB. Okay. So let's first prove that the triangles are similar. That is, triangle DEF and triangle ABC are similar. For that, if you observe, what is D? D is midpoint and F is also midpoint. D and F are midpoints of AB and AC respectively, isn't it? So you must remember that if you join two midpoints, it will be parallel to opposite side, that is the third side, and it is half of the third side, that is DF will be parallel to BC, and DF will be half of BC. Let's take this as equation 1. We got this equation 1. We got this equation 1 using midpoint theorem. I'll write it as MPT, meaning midpoint theorem. We'll apply the same stuff. Similarly, F is midpoint, E is midpoint. F and E are midpoints of F and E are midpoints of AC and BC. AC and BC respectively. Therefore, what do we get? We get FE is parallel to AB and FE is half of AB. Okay. Here, instead of taking this as equation 1, let's make a small change. Once again. Okay. Here, we'll get this BC the other side. So it will become DF by BC equals 1 by 2. Let's take this as equation 1. Similarly here, FE by AB will become 1 by 2. Let's take this as equation 2. In the similar fashion, if we do for the other one, that is D and E, let me write it directly. Similarly, we get DE parallel to AC and DE will be half of AC. Get the AC the other side. So DE by AC will become 1 by 2, equation 3. Now, if you observe equation 1 and 2 and 3, all the ratios DF by BC, FE by AB and DE by AC all are equal. Okay. From 1, 2 and 3, we can conclude that DF by BC, that will be equal to FE by AB, that will be equal to DE by AC. All the 3 equations are equal. Now, if you observe the numerator, that is, what have we got in the numerator? In the numerator, we have got DF, FE and DE. And in the denominator, we have got BC, AB and AC. What are those? DF, FE and DE are the 3 sides of the triangle DFE, isn't it? DF and FE and EF are the 3 sides of this triangle DEF, which we have shaded. And BC, AB, AC are the 3 sides of the triangle ABC. So what we have got here is, we have got 3 sides of the triangle DEF and 3 sides of the triangle ABC are in proportion. Therefore, we can conclude that triangle ABC is similar to triangle. See, we have to write the corresponding parts. That is, whatever angle that is equal to A, we have to write it here. How will we get to know it? Observe the numerator of the thing that I have marked in red. So in the first, here we have got, in the first 2 numerators, which is the alphabet that is same? F. Correspondingly, observe the denominator, which is the alphabet that is same in both. It is B, isn't it? B is here, B is here. In the numerator, F and F is same, which means angle B will be equal to F. Now, if you observe the same pattern for the next 2 numerators, E and E is same, A and A is same, which means A will be equal to E and C will be equal to D. This is using SSS criteria. So what we have done is, we have proved that the 2 triangles are similar using SSS criteria. Okay, let's draw a line. Let me continue here, the other side. Okay, so we have proved the 2 triangles are similar. Therefore, if 2 triangles are similar, area of triangle DEF divided by area of triangle, instead of DEF, it will become CAB. Okay, I'm taking the corresponding parts. Area of triangle DEF by area of triangle CAB or ABC, both are one and the same. That will be equal to squares of the corresponding sides. Out of this 3, Out of this 3, that is df by bc, fe by ab, de by ac. We can take any one. Let's take the first one itself. That is df by bc, the whole square, isn't it? It is square of the corresponding sides. But if you observe the equation 1, df by bc, the equation 1 is here. Okay, df by bc value is 1 by 2. So let me write 1 by 2 here, the whole square. So what is 1 by 2 the whole square? It is 1 by 4. Therefore, the ratio of, therefore, area of triangle DEF by area of triangle CAB or ABC is 1 by 4. Therefore, the ratio is 1:4. That's the ratio. So let's look at the problem again. So we have to prove that the green color triangle, the shaded triangle and the big triangle are similar, so that we find the ratio. How did we prove that the triangles are similar? We know D is a midpoint, F is a midpoint. So if we join two midpoints, that line will be parallel to the third side, that is BC, and it will be half of BC. That's what we have written here. DF is half of BC. Transpose the BC to LHS. It is in multiplication with half. So if it comes as a, come to the denominator. So DF by BC equals half. If we follow the same pattern for the other two midpoints, we get equation 2 and equation 3. If we observe equation 1, 2, 3, all are equal to half. Therefore, we can tell that the three ratios are equal. Interestingly, these three ratios are nothing but the sides of the two triangles. That is ABC and EFT. Therefore, three sides of both the triangles are in proportion. We can tell that the triangles are similar using SSS. Therefore, if the triangles are similar, we can use the property, and we have used it. We have got the answer. So let's get into the next question, students. So in the next question, we have to prove that ratios of areas of two similar triangles is equal to the square of ratio of corresponding medians. This I have already given it as a note or an important point when we were doing areas of similar triangles. We'll prove this now. That is, ratios of areas of two similar triangles is equal to squares of ratio of corresponding medians. Okay, let's do that. First, let's take two triangles. Let's draw two triangles. Let's take one more triangle. Okay. So let's name this triangle as A, B, C. And let's name this triangle as P, Q, R. We'll also draw the median. Let's say this is the median. Let's also draw a median here. Okay, let's say this is M and let's say this is N. Remember, this AM is a median, which implies M is a midpoint. That is, BM will be equal to MC and QN will be equal to NR, since they are median. Okay. What they have given us is, they have given that these two triangles are similar. Triangle ABC is similar to triangle PQR. Okay, it is given. If two triangles are similar, remember we can write the corresponding angles are equal. That is, A will be equal to P, B will be equal to Q, and C will be equal to R. Along with that, we can also write the corresponding sides are in proportion. That is, AB by PQ will be equal to BC by QR. That will be equal to AC by PR. We can write this, isn't it? What we have to prove is the ratio of the similar triangles. That is, area of triangle ABC by area of triangle PQR. Let me erase it. Area of triangle PQR is equal to ratio of medians. That is, AM by PN. If you remember in the video, one of the video, we had taken it as AX and PY. Instead of M and N, we had taken it as x and y. Okay, let's look at the proof. Now we know that since or as triangle ABC is similar to triangle PQR, okay, we can write this, isn't it? Area of triangle ABC. If two triangles are similar, then ratios of the areas is equal to squares of the corresponding sides. Let's take only the first one, AB by PQ the whole square. We also get the other two things, BC by QR the whole square, AC by PR the whole square. But let's take only one. Let's take it as equation 1. Now, instead of this AB by PQ, we should have what? AM by PN, isn't it? Instead of AB by PQ, we should have AM by PN. Okay, let's do that. Now, very clearly, angle B is equal to angle Q, isn't it? Let's take it as equation 2. How did we get this equation 2? It is given. Okay. And from the given data itself, let's take this AB by PQ is equal to BC by QR. Okay. This is also given. Now, AB by PQ is equal to, instead of BC, I can write it as 2 times BM, and instead of QR, I can write it as 2 times QN, because M and N are midpoint. So 2 and 2 gets cancelled. We'll be left with AB by PQ is equal to BM by QN. Let's take this as equation 3. What can we conclude from 2 and 3? If you observe carefully, angle B, look at the figure, angle B is equal to angle Q. One angle is equal, and sides containing the angle AB, BM. I'm talking about triangle ABM, and in triangle PQN, it is PN and QN are the sides containing the angle, and these sides containing the angle are in ratio AB, BM, PQ, QN. Observe the figure. The sides containing the angle are AB, BM, PQ, QN. The sides containing the angle are in ratio. One angle is equal and sides containing that angle are in ratio. Therefore, from 2 and 3, we can conclude that the triangle ABM is similar to triangle PQN. If the two triangles are similar, it implies the corresponding sides are in proportion, isn't it? Therefore, AB by PQ will be equal to BM by QN. I'll eliminate that. I'll take the last one, AM by PN. Okay. Corresponding sides are in proportion. Okay. Now substituting the above result, where in equation 1, that is, instead of, what is equation 1? Area of triangle ABC by area of triangle PQR is equal to AB by PQ the whole square. So instead of AB by PQ, what can we write? So area of triangle ABC by area of triangle PQR will be equal to, instead of AB by PQ, I can write it as AM by PN. So it is AB by PQ the whole square. So it will become AM by PN the whole square. So that's how we proved the two triangles are similar and the ratio of areas of triangle is equal to ratio of squares of corresponding medians. I once again repeated, the ratio of areas of two similar triangles is actually equal to 3 results. The first one is squares of the corresponding sides, or squares of the corresponding altitudes, or squares of corresponding medians. That is ratios, okay? Ratio of corresponding sides, ratio of squares of corresponding sides, ratio of squares of corresponding medians, or ratio of squares of corresponding altitudes. Okay, these are the 3 important results. Let's continue the next problem. So the next question, the seventh one. Prove that area of an equilateral triangle described on one side of a square is equal to half the area of equilateral triangle described on one of its diagonal. So we are forming two equilateral triangles, one on the side of a square, other one on the diagonal of a square. So we have to compare those two triangles and we have to find the areas. Okay, basically we have to compare the areas. Okay, so let's first take a square. Let me draw it here. Let's say this is the square. Okay, what is a square? All the sides are equal, isn't it? So let me say all the sides are equal to a. So all the sides are of length a. Okay, let me indicate only with the one side. Okay, it is understood all the sides are equal. Since it is a square, all the sides are equal and angle is equal to 90 degree. Okay, let me put the angle 90 degree and all the sides are equal. Okay, now let's take one side of the square. Let's take AB and let's construct an equilateral triangle. Okay, let's construct an equilateral triangle there. So from here, let me draw here a line, and from here let me draw this. Okay, this is an equilateral triangle. Let's name it as EAB. Since it's an equilateral triangle, observe AB value is A and AEB is an equilateral triangle, which implies this will also become A, isn't it? Because it's an equilateral triangle, all the sides should be same. So this is one equilateral triangle. Similarly, let's draw a diagonal and let's construct an equilateral triangle. First, let's draw a diagonal. Let's take a line from D. Let's join. Or let me take another color that will be easy to understand. Let me join. This is the diagonal. So using the diagonal as one side of the equilateral triangle, that is on this diagonal we are constructing an equilateral triangle. Okay, so let's construct an equilateral triangle. Okay, let me take this as some F. Okay, so the black color triangle is your one equilateral triangle, the other equilateral triangle is DFB, is the red one. So the diagonal of a square is given by the formula A root 2, that is side into root 2. We have taken the side of the square as A, so the diagonal value will become A root 2. So DBF is an equilateral triangle, which implies all the sides will become A root 2. So this is also A root 2. So this value is A root 2. Okay, so all the three sides are equal to A root 2. Okay, now the interesting task is we have to compare the, let's draw a line, let's do the other side. We have to compare the areas of the equilateral triangle. Okay, now let me tell this: triangle AEB and triangle DBF are similar triangles. Can you guess why? Why are they similar triangles? Because what is AEB and DF? Both are equilateral triangles. In equilateral triangle, let it be whatever equilateral triangle, all the angles are what? 60 degree, right? So here all the angles are 60 degree. Similarly, in other equilateral triangle, in the other one, all the angles are 60 degree, isn't it? So 3 angles in one triangle, 3 angle is equal to 3 angles in another triangle. Because, let me write it here, because both are equilateral triangles and and all the three angles in both triangles are equal to 60 degree. Therefore, they are similar using A criteria. Okay. Now, since they are similar, we can find the ratios, isn't it? So, area of triangle AEB by area of triangle DBF is equal to squares of corresponding sides. Let's take AE by DB the whole square. Let's not take all the three. Let's take only one. So what is the value of AE from the figure? From the figure, the value of AE is A and the value of DB is A root 2. So the whole square. If we observe A and A gets cancelled, A and A gets cancelled. So we are left with 1 by root 2 the whole square. That will become 1 square is 1, root 2 square is 2. So what we have got here is area of triangle AEB by area of triangle DBF is equal to 1 by 2. If I send that DBF, area of triangle DBF, the other side, implies area of triangle AEB will be half area of triangle DBF. So we have proved the result. So one triangle was formed on side of a square, other one was formed on the diagonal of a square. So this is how the figure looks like. So in that, we have proved that the triangles are similar because both are equilateral triangles. All the three angles are equal. So therefore, they are similar. Therefore, now we have taken the ratios of areas. It is equal to squares of the corresponding sides. So we can take any size because it's an equilateral triangle. It doesn't matter. So AE by DB the whole square. AE value is A. DB value is A root 2. Therefore, A and A gets cancelled. We'll be left with 1 by root 2 the whole square. So 1 square is 1, root 2 square is 2. So cross multiplying, we get the required result. So let's get into the next problems, which are MCQs. So the next question is ABC and BDE are two equilateral triangles such that D is midpoint of BC. So we have got two equilateral triangles again. Ratio of area of triangle ABC and BDE. So we have to find the ratio of triangle ABC and BDE. So let's do that. First, what we have got is a triangle ABC. Let's draw a triangle. Let's draw a triangle. Okay. The name of the triangle is A, B, and C. And D is such a point that it is a midpoint. Okay. It is midpoint. Let's say, which means if I take this equilateral triangle to be of side A, of measurement A, all the three sides are same. Let me erase it. Let me write it here. So A, all the three sides are of length A. So the BC is also A. If D is midpoint, so the length will become A by 2. And this will become A by 2. Okay. And we have got another triangle that is BDE. Let me take here. Okay. So this is also an equilateral triangle, which implies ED value will become A by 2 because BD value is A by 2. The other sides will also become A by 2 because it's an equilateral triangle. All the sides are same. We have to find the ratios. Again, both are equilateral triangles. So triangle ABC and triangle BDE are equilateral triangles, which implies triangle ABC is similar to triangle BDE using A criteria because all the angles are equal to 60 degrees, right? So therefore, if you find the ratios of areas, area of triangle ABC by area of triangle BDE That will be equal to squares of the ratios of squares of corresponding sides. So let's take the first one, AB by BD the whole square. What is the value of AB? A. What is the value of BD? A by 2. Okay. The whole square. So A as it is, if you reciprocate A by 2, it will become 2 by A, the whole square. You must have learned in the lower classes that A by B divided C by D. We keep A by B as it is into reciprocal D by C. The same stuff that we have done here. The numerator A can be written as A by 1 and the denominator is A by 2. So A by 1 as it is into reciprocal, it becomes 2 by A. That's what we have done here. So A and A gets cancelled. We are left with 2 by 1 the whole square. So 2 square is 4, 1 square is 1. Therefore, the ratio is 4:1. So the correct option will be 4:1. So similarly, let's get into the next question. So in the next question, sides of two similar triangles are in the ratio 4:9. Areas of these triangles are in the ratio. So let me do it here itself. Sides of two triangles are let me solve here in this box. So sides are given that it is in the ratio 4:9. Areas will be squares, right? Ratio of squares. So it will be 4 by 9 the whole square if you take the ratios. So it will become 16 by 81. Therefore, the ratio is 16 by 81. That will be the correct answer for the last one. So with this, we have completed this exercise. I hope you have understood. Thank you, students.